On the morning of August 22nd, 1986, rescue teams descending into the valleys around Lake Nyos in Cameroon walked into a landscape frozen mid-evening. 1,746 people were dead. Thousands of cattle, goats, sheep, and fowl lay dead in the fields, exactly where they had been standing. Not a single hut had collapsed. Not one window was cracked. Cooking fires sat extinguished in their hearths. Oil lamps and candles had been snuffed out mid-burn. Stacked kitchen utensils remained exactly where they had been placed the night before. There was no scorching, no blast damage, no wreckage of any kind. And yet every breathing creature for kilometers around, down to the ants in the soil, was gone. Survivors who woke the next morning beside their own family members assumed at first glance that the bodies beside them were only still asleep.
This is the puzzle that confronted investigators. What force can strip every living thing of breath across dozens of square kilometers of inhabited valley in a matter of seconds, while leaving every structure, every window, every stacked plate completely undisturbed? It was not an explosion, it was not a weapon, and it was not a disease. The answer had been sitting at the bottom of the lake itself for centuries, quietly assembling into a 210-meter deep chemical weapon before it fired without a single sound.
Lake Nyos sits inside a young volcanic crater formed by an explosive collision of rising magma and groundwater roughly 400 years ago. Beneath the crater lies a magma chamber rooted deep in the mantle, continuously bleeding carbon dioxide upward through fractured granite. That gas dissolves into groundwater far below the lakebed, forming a heavy, mineral-rich, slightly warm fluid that seeps into the lake floor through underwater springs at a depth of around 190 meters. Under normal circumstances, gas seeping into a lake simply bubbles to the surface and escapes into the atmosphere. Lake Nyos does not behave like a normal lake. It is meromictic, meaning its water column is permanently divided into layers that never mix. A thin surface layer extends down to about 10 meters. Below that lies an intermediate layer, and below that, starting at roughly 120 meters and continuing to the lake floor at 208 to 210 meters, sits the Limnic, a deep, isolated body of water that had not touched the surface in centuries. The physics that trapped a chemical bomb down there is simple and unforgiving. Water pressure increases with depth, and the solubility of carbon dioxide increases with pressure. At the lake floor, the water sat under roughly 21 atmospheres of hydrostatic pressure, more than 20 times what a swimmer feels near the surface. Combined with the cool, stable bottom temperature of around 25 degrees, that pressure let the deep water hold an extraordinary amount of dissolved gas, up to 3% of its own weight in pure carbon dioxide. For centuries, magmatic gas crept in from below, and the deep water simply kept absorbing it without ever releasing a bubble to the surface. By the time of the disaster, the Limnic is estimated to have held roughly 600,000 tons of dissolved carbon dioxide, drawn from an underlying geological reservoir that geologists estimate may hold as much as 90 million tons in total. Dissolved carbon dioxide is not weightless. It measurably thickens water, adding roughly 0.7 kilograms per cubic meter to the density of the deep layer. Dissolved minerals carried up from the same springs, iron, magnesium, calcium, and bicarbonate, added roughly half a kilogram more. Together, that dense, gas-saturated bottom water became heavier than the slightly warmer water above it, even though warm water would normally rise. The crater is also deep and sheltered from wind, so surface waters never cooled enough to trigger the seasonal overturn that flushes ordinary lakes once or twice a year. With no mixing and no turnover, the lake became a sealed pressure vessel. Even microscopic bubbles that tried to form near the bottom could not survive the crushing weight of water above them. They dissolved back into the surrounding fluid within about 60 meters of the lake bed. For roughly 2 centuries, the system held. The lake looked calm. Fishermen paddled across its surface. Villages grew along its shores. Underneath them, an invisible column of pressurized gas kept climbing toward its breaking point. Sometime in the early hours of August 21st, that equilibrium failed. The exact disturbance that started the chain reaction, whether a rockfall, a sudden cooling of the surface, or simply the accumulated gas overwhelming the density barrier holding it down, remains debated among researchers who study Cameroon's other gas-charged crater lakes. What is not in dispute is the mechanism that followed. Once a pocket of saturated deep water was pushed upward, even slightly, the falling pressure around it caused dissolved gas to begin exsolving into bubbles. Those bubbles made the water lighter, so it rose faster, which dropped the pressure further, which released even more gas. The chain reaction fed itself faster and faster until the entire deep water column was erupting upward like a bottle of soda shaken open from below. When the eruption breached the surface, it tore loose an estimated 1.6 million tons of carbon dioxide, along with a violent surge of water that produced a wave roughly 24 to 25 meters high, stripping vegetation from the shoreline, the only place the disaster left a visible mark on the landscape. But the water was never the danger. Carbon dioxide is roughly 1.5 times denser than the air we breathe, and the enormous cloud boiling out of the lake behaved exactly like a liquid. It did not disperse upward into the atmosphere. It fell, forming a ground-hugging current 50 to 100 meters deep, and began flowing downhill, following the valley floor at speeds of 20 to 50 kilometers per hour. For nearly 25 kilometers, an invisible, colorless tide of pure asphyxiant rolled through the valleys, exactly as water would, pooling low, drowning every village on the valley floor, and leaving the ridgeline settlements, some barely 120 meters higher, completely untouched. Inside that cloud, the physiology was merciless and fast. At concentrations above roughly 10%, carbon dioxide overwhelms the body's respiratory drive within minutes, causing rapid loss of consciousness. At the concentrations found closest to the lake, over 40%, breathing and awareness shut down within a few breaths. Forensic autopsies on hundreds of hospitalized survivors confirmed carbon dioxide asphyxiation as the sole cause of death, and the pathology told its own story. There was no agonal struggle, no thrashing, no clawing, no defensive posture, because the gas displaced oxygen so completely and so instantly that the body simply lost the ability to react. Roughly 1 in 5 survivors was found with fluid-filled blisters on their skin, and for a time, investigators mistook them for chemical or thermal burns. They were not burns. Pathologists eventually identified them as pressure ulcers, formed because the gas acted as a powerful anesthetic, dropping victims into comas lasting 6 to 36 hours while they lay motionless on the ground, blood flow cut off beneath their own body weight. Many survivors also described a phantom smell of sulfur and a flush of warmth as the cloud arrived, both later proven to be hallucinations, carbonic acid irritating nerve endings, and carbon dioxide dilating blood vessels beneath the skin. There was no sulfur in the gas at all, and it was never hot.
By the following afternoon, the cloud had thinned into the wider atmosphere until it was gone. The lake's surface turned a rusted, unsettling red for a while, as iron carried up from the depths met oxygen for the first time in centuries. Engineers later installed degassing pipes to bleed the remaining gas out safely, because even years afterward, pressure at the bottom of Lake Nyos was measured still climbing, proof that the magma chamber below had never stopped feeding it. The valleys have been rebuilt. The lake looks peaceful again, blue and still. But the geology underneath it never went anywhere. It is still down there, in the dark, at the bottom of a lake that looks like any other, quietly building pressure that no one above the surface can see, hear, or feel, until the day it decides not to be quiet anymore.